Hello everybody, and welcome to my presentation for a class at the University of Advancing Technology. And that class is CSC 370, Artificial Intelligence. So today I had to write a program that uses some artificial intelligence, and what we're trying to do is balance a pole on a cart. And the cart is going to move side to side, and I wrote a little bit of a program here that has a policy in it that says if the pole is starting to lean to the left, then move the cart to the left to try to straighten it out, and if it's the pole's moving to the right, then we're going to move the cart to the right and try to even it out. Now, this is not a machine learning type of algorithm. This is more of a rules-based algorithm where we're basically just saying that, you know, if we're sensing some movement on the pole to the left, then we're going to try to correct it. Now, here's the thing. If the pole reaches 12 degrees or more leaning to one side or the other, the program's going to stop. Also, if the cart moves too far to the left or too far to the right, it'll stop. So let's get into the code really fast, and I'll show you what's going on here. So we're using a library called Gem, and that gives us a bunch of tools to use to create something like this. And so here's what we're going to do. We have to make an agent, an environment, and a policy. The agent is to follow the baseline information for the environment based on states or observations. Okay, so here's how this works. So we're going to write a program that's basically going to print out some information for you to see, and it's going to run constantly while this thing is trying to balance itself out. So we're going to run it up to 200 times. And now this can fail before that if the pole, you know, kind of goes too far left or right, or if the cart goes too far left or right. But you'll see that when we run it. So basically here's what's going on here. In the action space, if the number's 0, it's going to push the cart to the left. If it's 1, it's going to push the cart to the right. Okay. In the observation space, we have 4 different observations we can look at: cart position, cart velocity, pole angle, pole velocity at the tip. And all of this is being calculated, you know, under the hood, basically. So here's how we're going to make the environment. We give it a name, and we're using cart pole version 1. Environment equals gem. We make the environment right here. We have a render mode set to human so that we can actually see it. Uses Pygame to kind of show us what's going on here with that. So basically, in layman's terms, we print out an observation space and an action space. Okay, now here's the thing. So we make a class called agent. Now this agent is basically the thing that's going to run. It's the object. Okay. We do that by using this code right here, and then we're going to print it out. So we set the self action size equal to the environment action space, and then we do the same thing for the state size. We use observation space for that. Now we define a function called getAction. This is going to check to make sure things are working right. If not, it's going to spit out an error message. And that squeaking in the background is my obnoxious parrot. And if he doesn't stop, he's going to get punished. So you hear that, Phoenix? Okay, moving on. He'll try to be good, but it's in his nature not to do so. So we'll just keep moving on and ignore him. Okay, so basically here we're going to get the angle of the pole by using this state. And see that 2 in there? Well, if we go up to 2, back up to here, that's the observation space. We're going to use that number 2 to get the pole angle. So in other words, there's an algorithm behind this that says if these numbers are present, if we use these numbers, then we can get this information. And Phoenix agrees. Okay, so now we know that. Alright, so here's the nuts and bolts of it. So here's the thing. So once we get that state, we can get the angle of the pole. And if the pole angle is less than 0, okay, then we set the policy action to 0, which means when the action is set to 0, remember the cart's going to move to the left. Now, if the pull angle is greater than 0, then we're going to push the cart to the right by setting the policy action to 1. And we do that by returning the policy action in this class. Okay, here's how we create the agent. Basically, we just have, we instantiate an instance of 1. And then we print the initial state. We have a loop here of 200 cycles, and we print out a bunch of stuff here. Right here is how we print it out. So what's going to happen is it's going to update every time this thing runs, and we're going to update it, and it's going to show you what's happening, and it's going to try to compensate for it. It's going to try to balance it out, but in the end, it's probably going to fail before the 200 times. It'd be nice if it does, but like I said, this is a rules-based policy and not a machine learning policy. So I slowed it down a little bit so we can see what's going on. And at the end, it will tell us if we won or reward. If the thing is, if it's been terminated, it'll also tell us that the environment has been reset at the end, and make some pretty stuff so we can read it better. Okay, layman's terms done. Now let's run the program. You guys ready for this? Okay, so here we go. So as you can see, it's updating, it's giving us the angle, it's telling us that there's a reward, and you can see that the cart is trying to balance the pole. So remember, if that pole gets over 12 degrees, it's going to stop, and it did. So that's basically it. So if you look, it ran, let's see here, 48 times before it terminated. So here's what this all means. Oh, there's a typo in here. I have to fix that. It's supposed to be starting the current time step, and it's looping through this time step of up to 200. It gives us the pull angle. It tells us the action to take. So because this is greater than 0, right? What's going to happen? What's going to happen if it's greater than 0? So let's take a look. So if the pull angle is greater than 0, we're going to move the car to the right. And let's see. So, yep, action to take is 1. That means we're moving the car to the right because the policy action is 1. And it's printing that out. So it's also telling you that we got a reward of 1. That's set up for the machine learning, and we'll go into that later. But this says it was terminated, which means it ended because it basically fell without the bounds and stuff like that. But anyway, if you look, you can see that if we go up here, if you look, you can see that looking at the pull angle, we can figure out what we need to do, and it will take that action. Then it brings you to the next state. It gives a reward. Terminated means that it failed the test and it's going to stop. Truncated means that it won. It got through all 200 things and it won. Info's not integrated yet. So anyway, so if you're looking at all of this, we can get some valuable information, right? So we can see the pull angle. We can see how many times it ran through. We can see the action it take, either move it to the left or to the right. The next state, if it got a reward, if it terminated, if it truncated, and any info that we're going to put later. And it does this every step. So it did a pretty good job. Look at that. It went all the way to, what? This time it went to like 47. And then it said that the episode has ended, and it tells you this the agent has either failed or passed. And it tells you how it did. And obviously it failed, so it terminated. So let's run this again. I'm just curious if there's going to be anything different. Here we go. I think this is amazing. You know how this works like this. I mean, it's actually trying to figure this out, you know. This time it ran 34. Okay. I want to do it one more time for us, guys. just to see the randomness of this. Now, how cool is this? This is like the coolest thing ever. You know, I mean, we wrote a program that tries to balance a stick on a cart. I mean, come on. This is awesome. 42. Okay. So anyway, that's that. This is my presentation. Thank you guys very much. And if you like what you see, Professor, give me an A. I can sure use it. All right, guys. Have a wonderful night.